originally were below. And here we have these heap of pancakes in the deposits with distinct boundaries between them. It is the aerial photo of this feature, very large, and here on the easily attainable right bank of the river we could study it in details, and we see that its upper part is composed of huge angular boulders, while lower part of heavily comminuted material crushed at a very large extent. This whitish unit was granite, this one was sandstone, but both are crushed, sometimes up to powder. One more good example featuring the same situation. The Ornok rock slide, also in the central Tian Shan. We see quite well these concave headscarp about 1.5 kilometers wide. And we see the body. But the body is not only this part. The body is here. And now let's look how this section look like from somewhere here. We see well stratified layers of debris, and we see neogene bedrock well inclined here, here, and here, and at the background there is a Paleozoic bedrock. But here we have just layers of material. The upper one came from Paleozoic, while lower came from Neogene, and all the succession rest on the alluvium. Such stratification of rock slide deposits, along with preservation of the original lithological sequence and dual structure with coarse blocky carapace and intensively crushed lower or internal part of these deposits, is a characteristic feature allowing sound discrimination even of those rock slide deposits that are poorly preserved in the relief. Here is a good example. Very old, Pleistocene, the so-called displaced peneplain rock slide in the Kokomaran River Valley in Kyrgyzstan. Dashed line marks its boundary of the deposits that remain up to now. Red arrows mark the headscarp crown, and blue arrows mark the original position of the river. This rock slide completely blocked the river. This small ridge originally was on the left bank of the river. We will see how it looks like from this side. And now river had to form the bypass gorge. Here we can see it is the headscarp zone, rock slide deposits, and at this part we can see this outcrop with bedrock closer to the river and alluvium here that remain in the abandoned inlet of the blocked river valley. So originally river came here, and only after rock slide it was, say, pushed and had to erode a new gorge left from this outcrop. One more view of this site. We see large rounded alluvium boulders and bedrock here, and the river now is on the left. And sound conclusions on the origin of this body was based on the careful study of old landforms and of the material of the deposits characterized by inverse grading, typical of rock slides and rock avalanches. And here we see intensively crushed material of the lower zone. Based on these characteristic features, we can discriminate rock avalanches and moraines. It is well known that numerous debris accumulations left by rock slides that are considered now as classical case studies had been interpreted initially as being left by glaciers. Their reinterpretation was made in the Alps by Albert Heim, in the Cocomaran by Kenneth Hewitt, and in many other regions by other researchers. I will present here several case studies from the Central Asia region that were recently described as end moraines and will demonstrate their geomorphic and structural peculiarities that allow considering them as large-scale catastrophic slope failures. One of the main and the most sound arguments in favor of glacial origin of numerous intact and partially eroded debris accumulations in the formerly glaciated river valleys in the Pamir and the Tian Shan mountains is the presence of large amount of moraine material in these bodies. However, careful analysis of debris distribution shows that this phenomenon can be explained in different way. A good example, the Imam rock slide in Pamirs. It is very distinct, fresh headscarp. And the body. Body is recent, overlying this debris flow fan. Indeed, when we come to the site and look here, this outer belt is composed of rounded, semi-rounded boulders with some debris sandy fill, typical of moraine material. But if we cross it and go in, we will see that all internal part of this body is composed of crushed gneiss, typical of this ridge. Another example from the same region, the Langar rock slide. Again, we have the headscarp, we have the body, which outer part is composed of moraine material, while most of the body of crushed bedrock. On the background, it is marked by YRS. It is the Yashelkul rock slide, which I will describe further. In both cases, rock slide body composed of crushed bedrock, bulldozed moraine material left by old glaciation, and remaining along the feet of the valley slopes. It bulldozed in front of it. More complex mechanism took place during formation of this Yashelkul rock slide dam in the upper reaches of the Gund River valley. Here is the view. It was proposed that the river, the main river, initially was blocked by end moraine first that came from this gully, and later this dam was overlaid by a rock avalanche, like this. There is no need, however, for such complicated interpretation. All observable phenomena can be explained by single event catastrophic failure of several tens of million cubic meters of gneiss. The source slope base was covered by the moraine of the either along valley Pleistocene glacier and likely by moraine or fluvio-glacial deposits from the tributary valley that I showed before. Rock slide bulldozed this material into the stream, blocking the river, while coarse gneiss fragments spread over forming a relatively thin blocky apron. Some moraine material spread in front and aside the blocky part and formed the well-visible outer zone of rock avalanche. Let's have a look. Here it is the Google Earth image. We have this headscarp, this tributary valley, formerly glaciated, very distinct rock avalanche, dark, coarse material, but we see this outer zone and this frontal zone marked by black arrows. And now let's look how it looks like in the field. Please, it is the original surface. formed